Okay, I'm going to have a look at some graphing of e to the x. So this is starting into some Unit 3 work for Maths Methods, just going over some concepts related to e to the x. It will be, like this is the basis before you get into finding the derivative of e to the x. So things to know about the e to the x graph. So the basic shape is it's cutting through here at 1, because anything to the power of 0 is 1. And there's our shape approaching 0 here and then heading upwards. Now, the best way to get a feel for what these graphs are going to look like is to do some comparison ones. So firstly, putting in the e to the power of x. So looking on your graphics calculator here, we've got our e there, put to the power of x. So I've got that in my calculator. I can graph it. Now, looking at my window there, I've had it had the settings a little bit different. So I'm going to go -10, 10, and bring this back to -10, 10 here as well, just to get my basic shape there. So you can see approaching 0 there, cutting through at 1 and heading upwards. Now, the first one I want to have a look at is if we had 2e to the x. So then I'm going to bring down here, do my e to the x, and I'm going to have a look at the shape and see what has happened between the red and the blue. So you can see as we have graphed that it's now cutting at 2. Now that makes sense, because if you've got two lots of, if you do e to the power of 0, you get 1, 2 lots of 1 is 2. So we can see that the y-intercept has become 2 and it's a bit steeper there. So that is changing our shape in that form. If we put a half in front, we can see, and we would expect that it's going to cut lower and then go up. So there's our difference when we put that coefficient in front. So it's changing the y-intercept. And also the steepness of the graph. Because we can see we've still got our approaching 0 there, it's just changing where it cuts and that steepness of our graph there. The next comparison I wanted to look at is if we put a number on the end. Now, hopefully you've got some memory of when you did your transformations of quadratics, that when we did a +1 or a minus, we were getting a vertical shift. The same with our trig functions. So I'm going to leave my e to the x there. I'm going to delete the number that was in front and then put a +1 on the end there. I'm going to delete this one here so that I can just look at those two there. Now what we're expecting is a vertical shift. And so here's our graph coming. We can see that there's that vertical shift of 1, and obviously it also changes the y-intercept to +1 as well, because if we're adding 1 to your result, that's going to add 1 there too. So then we would be expecting, if we then did e to the x take 2, that we would see that shifting down vertically. And we can see that that's down 2. We can see that if it was originally crossing at 1 and we've taken 2 away from that, it's at -1. And then the graph there. So we can see that a plus or minus on the end causes a vertical shift, and obviously changes your y-intercept as well. The next one I want to look at is if there is something added to the x up the top. So we've got our e to the x there. Here we're going to take that +1 away, and we are going to add a +1 up here. I'm going to delete this one altogether so I can just look at those first two graphs. Now, when we had a +1 on the end, we saw a vertical shift, so we should be able to assume that we're going to have a horizontal shift there. So having a look at our original graph there in the blue, when we then bring in our red, we can see there's that horizontal shift there. So it is now cutting at 2, and we can see that it's that turning area is earlier. If we did the e to the x take 2, we would assume we're going to have that shift forward then. And there we go, we can see that that has shifted forward. So you can see that that is going to do a horizontal shift. We can then have a look at a couple of little extra ones here where we have y equals e to the negative x. So we've got e to the negative x and having a look what's happening there. So here's our original in the blue, and then our -1 is the, hopefully coming soon, yes, the reflection in the y-axis. So we can see it's coming down that way. When we do the negative in front, we're going to assume that we're going to get another reflection, but this time it's going to be in the x-axis. And there we go, we've got it coming down there. So there's a couple of features to look for with your e to the x. The last thing that I want to look at in this video is if we're solving. Now when I see one like this, and I know that I can solve it on my calculator, so as long as it's not tech-free, grab out that calculator and use it to its capabilities. We have got e to the x is equal to x plus 2, so I'm going to put in, I'm leaving my e to the x, that one can stay, and then I've got x plus 2 is my other function. When I graph them, I'm looking for the intersection. So here's my x plus 2. I can see that it intersects twice. So if I put my trace on, get it close to the first one, so I can see that it's about -1.6 and 0.1 for my y, do my second trace and my intersect, it will then find that one there that it's closest to, so the -1.84 and the 0.15. Then I'll put my cursor over on the second one, close to where that intersection is. It's about 1.21, 3.36. Then use my second trace, my intersect, and it'll find that second one for me at 1.14 and 3.14 there. Okay, hopefully that helps you with your graphs of e to the x.